All right. Welcome everyone to the finals of Hack3D 2024. This is our 9th annual competition that we've ran. I'm going to start off with just a small presentation. So, welcome once again to the finals for Hack3D 2024. Hack3D is our annual competition as part of the Cybersecurity Action Week, where we bring awareness to problems in digital manufacturing and cybersecurity, where any point along your manufacturing stage, such as the design phase, the testing phase, your manufacturing, and your post-testing, all of these are vulnerabilities for cyber attacks, such as sabotage, piracy, and counterfeiting. The organizers of this event are Dr. Nikhil Gupta, Dr. Ramesh Carey, and myself, Caleb Beckwith. And this year we had a lot of help from the VIP team at New York University, where these undergraduate students, they designed the problem, they sent out the leaflets to everyone, and they did their best to put on a great show for you all today. Congratulations to all of our finalist teams, Team Augmented Realm from India, Team Greeks for Geeks from Athens, and then Team Tesseract from Columbia University. You all did a fantastic job with your preliminary round and from what I've seen from the final round. Our judges this time around are Dr. Carlo Canetta, who got his PhD from Columbia University. He is currently the department manager for the Mechanical and Reliability Systems department at, prototype development at MITRE, and Stephen Lee, a master's graduate from New York University, who's now a software development engineer at Amazon. The final round consisted of a problem where a thief had stolen files, and your job as the participants was to uncover the identity of the thief. Some of the CAD files you got were useful. Not all of them were entirely useful, and you all did a great job of uncovering which was which, and we will see that later today. As far as the presentation order, Team Augmented Realm will go first, followed by Greeks for Geeks, and then lastly Team Tesseract. But before we get on to the presentations, let's have a word from our judges real quickly. So if Stephen or Carlo would like to say something.
Carlo, do you want to go first?
Yes. Can you hear me?
Yes.
Yep, we can hear you.
Sorry, just looking for the audio button. Hi all, good morning. Look forward to hearing the presentations from these three teams. As Caleb said, I'm with the MITRE Corporation. I'm a department manager there, and I'm involved with advanced manufacturing strategy development. So again, look forward to hearing from you.
Thanks, Claire. Yeah, same. Look forward. So my background, as Caleb mentioned, I used to be a I graduated my master in NYU, and with a computer engineering background, and also I had a mechanical engineering background with master and bachelor degrees from University of Colorado Boulder, and currently I'm a software engineering at Amazon. So look forward to see the competitions.
Fantastic, and we appreciate both of you for being here and taking time out of your day. So let's begin. Anyone from Team Augmented Realm that wants to project their screen and share their presentation, you can do so now.
Ashita, are you from the team?
Yes, sir. Just a minute, I'm sharing.
Okay.
Is my screen visible?
Yes.
Excuse me, am I audible?
Yes, we can hear you.
Yeah. Good morning, everyone. This
So-
is team.
Yeah, please introduce yourself quickly with your education background, your major or department, what level are you at? And then you can start.
Yes, sir. This is a team augmented realm from National Institute of Technology, Tiruchirappalli, India. My teammates are Ashita Sham from BTech final year in Electronics and Communication Engineering, and myself, BTech final year from Production Engineering. Yeah, Ashita, next slide. Yeah, actually, to be short, we've taught the password is Violet Pride. We will tell the reasons why it is, why we found this. Because in this statement, it was given me to find a code for this. Ashita, next slide, please. Yeah, first our brainstorming session. How we did the brainstorming was, first we tried for checking any comments that are hidden in the step file. Since we cannot able to find it, and we tried opening in the file in SolidWorks, but it showed some tessellation not found error. So we used a step file analyzer from NIST, nist.government.gov website, that gave the pure step file, and then we tried slicing the step files, like slice step by step, like how we make for a 3D printing, like how a slicer will work, like that. We did that, and then inside also we didn't found anything except, yeah. Ashita, can you move next? And in the first one, there were 6 files. In the first file, what we analyzed is that the file represents a fingerprint. So it and then also a QR code was embedded in that. Ashita, can you move to next? Since it is a digital one, and the person which was shown through that QR code doesn't seems to have a hand, so it might be something related to cybersecurity. That is not a physical hand, but he must have left some digital fingerprint on the website or some files by modifying it, by changing the checksum value, like that we thought. Yeah, next. And then the third file, we are in the third file, it is mentioned as the Emmy Awards. So we searched about the Emmy Award receivers. And the next file. And since the Emmy Awards are related to TV series, then the file 2 is related to some Eiffel Tower. So we thought something European related or something related to London, we thought. And then we also sliced the model to see whether any objects are hidden inside the Eiffel Tower. But we can able to find a QR code pattern from the bottom, but it is not a QR code. Even we tried with using the wireframe viewing model too. That also no QR code is found. Next slide, please. And then in the file 4, it is actually yeah, purple or violet box is covered the NYU. So we thought that yeah, some data must be related to the New York University, must be stolen by the hacker. And as previously the Eiffel Tower, it must be related to something European related thing. Next slide. Next slide. And then in the file 5, the model is given as Braun Nizo S800, which is a camera which are widely used in 1970s to 1977. So we we searched in the website for this New York University recipients, like TSOP, mostly TSOP people, so TSOA, from those college who all graduated, and what all Emmy awards they received, we searched on that. Yeah, next slide. And also in this camera, it for the knob, the slow motion knob, it is showing 54, but actually it is pointing to the 18. So that we thought some clue must be hidden in that. Yeah, next slide. Then also in the file 6, it is a crown is mentioned. So we thought crown refers to something a royal thing. And as we saw in the New York University website of Emmy Award recipients, in which we found two of the TV series which must be related ones are Palm Royale and the crown, the farewell to the royal epic. Next slide, please. And based on the this is this is the information that we found from the internet. That is, just before 1 month, New York University had posted the Emmy Award recipients. So we thought the website, the TSOA school website was mentioned in that. So we opened that and then we went through what all the films they made, and then we went through those one, and then we finalized the crown, the farewell to a royal epic, because that year is something 1993, so which is close to 1977, like some 16 years difference is there. So we thought this must be the more related one compared to the Palm Royal TV series. Yeah, next slide. And this is what we concluded. As per our conclusion, we concluded that the victim whose data was stealed was Alison Deknatel, that is the director of the TV series, the Farewell to the Royal Epic. So, and also in the previous slide, LinkedIn, it is mentioned that Violet Pride hashtag is mentioned. So, also in the fifth file also it is mentioned the purple or violet color was enclosed to the NYU. So we thought that Violet Pride must be the password or code to the final destination. Next slide. That's it from our side.
All right, thank you very much. Since we have a little bit of time, do our judges have any questions for the teammates?
I can go first. I have one quick question. So when you're doing when you're exploring the models, 3D model, CAD models, what kind of technical terms you used or technical skills you use? I remember you mentioned you use slicings, but what is there any features, tools used?
Yes, sir. Actually, for that sectional view, we used sectional view by changing the sectional plane. Like that, we used it, sir. And we used NIST.gov website that provided a step file analyzer. We used that to clean the errors. So that one we used, sir, because in SolidWorks some files showed a error, but when we open that in the Autodesk step file viewer or Onshape in the online, then it is opening, sir.
Thank you.
Yes, sir.
Very nice presentation. If I may ask a question, back when you were talking about the digital fingerprint file, you mentioned the consideration of changes to the hash file. Did you find anything there?
No, sir. We didn't check any checksum values, sir, because if we know the original checksum only, we can find. So we didn't check the hash values. But we thought the crime must be related something based on the hash value.
Understood. Thanks.
Yes, sir.
You also mentioned, sorry, just looking through my notes, on slide 3, I think relevant info found on the internet. Was that pertaining to that the digital fingerprint file specifically, or was that a comment on kind of overall the approach and the methods used?
Sir, slide 3, sir.
Sir, could you repeat your question?
Yeah, so the question is, there was a bullet point, I think it was slide 3, or one of the early slides, about searching relevant info on the internet. And I was wondering if that was a comment specifically pertaining to the digital fingerprint file and what information you gathered, or if that was a general comment pertaining to approach methods overall.
Yes, sir. Actually, that is based on the Emmy Awards and the NYU related, like that we searched on the internet, sir. Like that only we found the LinkedIn post for the Emmy Awards.
Understood. Okay. Yeah, I misunderstood it then to be pertaining to the methods of investigating the digital fingerprint file. But thank you.
Yes, sir.
Thank you so much for your presentation. You guys did a great job. Let's move on to Team Greeks for Geeks.
Hello, I'm Christos. I'm from Team Greeks for Geeks, and I will be doing today's presentation. Just give me a moment to prepare the screen sharing. Can everybody hear me and see my screen?
Yep, you're good.
Okay, thank you. So we're Team Geeks. We support people, me, Christos, Nicholas, George, and Stasinos. We are all fourth year students in electrical computer engineering at the National Technical University of Athens. So first, we would like to talk a bit about our approach to the problem. We download the files, we open them first in VS Code or Notepad to see if there was any useful information or any hints. Excuse me?
Your voice is not clear, Christos.
Oh.
We are hearing a lot of feedback.
Let me give me a moment to get all the settings right.
Christos, I can help. If my internet is better, I don't know.
Can you hear me now better?
We can hear, yeah, we can hear Nick very cleanly.
Okay, so maybe I can continue with the presentation if you want. I can help.
Sure. Sorry, can you hear me better now?
It's a little bit better. Yes, you can continue and we'll see.
Okay.
Okay. So we downloaded the files, we viewed them in a VS Code or Notepad in order to see if there was any clues in the metadata of the files. Then we opened them, we used Fusion 360 from Autodesk to look at the 3D models. We looked for any abnormalities, and we kept logs for every step we made. So we will talk about each file separate. The first file consists of a QR code and a fingerprint. The first thing we did, we looked at the fingerprint. So because we had seen in the metadata that the name of the file was fingerprint11. So
I'm sorry to interrupt, but your audio was good for a couple of minutes and now it's back out again.
Okay, then probably I can continue the presentation. I will add at any moments.
Okay, Christos, you continue with the screen sharing. I will be talking, and I will say next if anything happens.
Sorry about the technical difficulties.
Yes, internet in Greece is a bit bad in general. So our team, we have Christos and Yorgos, who are better with 3D models, and me and Stasinos are better with coding and code breaking. We all have experience in different areas, so we took advantage of these strengths. But however, we did not split the tasks. We were all together, and we would brainstorm, find ideas, and split them on the go as we were continuing. So let's go on file 1.step. Here we saw that the QR code and the fingerprint were on top of each other. We separated them. We scanned the QR code and we saw the image. Nice try. We thought it could be a dead end. We weren't sure. So we looked at the metadata of the image before continuing. We also noticed that the fingerprint had a whirling pattern. It's one of the 4 different types of main characteristics. And maybe we can continue the next slide. So that those were potential hints we noted. We were not sure if the image was a dead end, so we performed a Google image search and found many different nonsense images from Amazon that were fake. We looked at the image metadata to find links. We opened it as a text file and found different links that weren't actually going anywhere. We didn't want to waste any more time, so we just wanted to note that there was a typo. We didn't know if it was a clue or not, but we noted it just in case. Next slide. So for the file 2.step, we saw the Eiffel Tower. We looked around, we looked underneath, we removed the base, which was the only different part that compared to the actual Eiffel Tower, the base is not like that. So we thought we might remove that part, we might hide it. We did different tricks in order to see underneath. We also sliced it. We did not find any different patterns on the Eiffel Tower. We then measured it to see if the scale is correct. It was 1/100. That did not help at all. We opened the file 3.step. It was an Emmy award. We thought that the thief might be French and might also be an actor who has won an Emmy or has participated in a series that has won an Emmy. We were not sure. We also noted that the prize did not look like an Emmy, but we thought it was just so to make it easier to render. Let's move on. File 4.step, the NYU board. So it had a weird background, the purple black box. We thought it was clipping inside. Something is wrong with this. So we thought we should take the letters out. We took them out. We looked around. We checked in different types of rendering styles like mesh, wireframe. We checked different ways to see inside. We also sliced every single one of these objects. We did not find anything. File 5.step is an ISO S800 camera that uses Super 8 film. It was used during films in 1970, 1977. It's a vintage film camera. We thought it would be important to look at French directors that use this camera. We were not sure yet. We also noted that that purple square box we can see down on the right. In the normal NISO camera, it's transparent. We thought that purple might be noteworthy. Let's move on. File 6.step, the crown. We knew the Crown series was really famous. We thought about Timothy Chalamet, who has played the king. We also thought about King Elizabeth, maybe a biography or something related to her could have guided us to find something. Okay, character profile. So we concluded that our thief has some specific characteristics, has appeared in a TV series, has been awarded an Emmy, is probably French or European or something related to France, has had a role of a king or a queen or was associated with one in some way, and has graduated from NYU or other, or the acronym is related in some way with NYU.
So the list of possible suspects. First, we thought about Timothy Chalamet. He ticked many boxes, but the only box he didn't tick was the camera. He's very young, so he's very old. Then we thought about another actor, a director, Sofia Coppola, son of Francis Ford Coppola, Francis Ford Coppola. She ticked a lot of boxes, but she didn't have a very strong affiliation with NYU. And we're starting to think about the NYU clue a bit more. Then we thought about Woody Allen, but he didn't have a very famous king or queen reference to attach him to the crown. And then we thought about Andy Warhol. It was a bit out there, but if you remember from the first, from the fingerprint clue, the world sounds a bit like Warhol when you say it with a bit of a New York accent. And then we thought about the colors in the QR code. They could look like an Andy Warhol painting. We also found out that Andy Warhol owned a house and lived in Paris and New York. He went from New York to Paris, and recently, and the Andy Warhol Diaries TV series was nominated for 4 Emmys. Continuing with Andy Warhol, he made movies through the 1960s, 1970s, many of them from 1970 to 1977. And also he made a documentary on the Velvet Underground, and that was shot with Super 8 film. if you recall that the NYU logo at the camera had velvet color in them. And also in the slide you can see his portrait in Queens, which is not for Queens, especially Queen Elizabeth. And so that would be his connection to the crown. But the thing is that the NYU, he's not connected to
Christos,
NYU, right?
Christos,
Yes.
maybe you want to switch off your camera because we are not able to hear you properly.
Okay. Sorry about that. Can you hear me now better?
It's better.
Sorry about the technical difficulties. Is there some I'll go from where. So lastly, the most important part is that Andy Warhol was not connected into meaning with NYU, but then we thought about if NYU didn't mean New York University. So we saw that the letters in the NYU object were a bit under the surface of the object. So we thought about, and that didn't mean NYU, but meant New York Underground, like underground artists like Velvet Underground, which was covered by Andy Warhol. So we conclude that the suspect is Andy Warhol that did the data breach. And that's the end of our presentation.
Thank you guys so much. A very great presentation. If Carlo and Stephen have any questions for you now, they're free to ask.
Thanks, Caleb. Nice presentation. I'm curious, and you did a nice job, I think, walking through the thought process and the kind of how you interpreted clues along the way. I'm curious, as you looked at the CAD files, did you look for kind of hidden information embedded within those files? And if so, can you talk about, what methods or approaches you used?
Yes,
Well, I'll think. Okay.
yes.
I can take this one. We started looking first on the text format of the files, like in a text editor, and we didn't notice anything out of order, apart from one small detail in the name portion of the step file. Only the first file had anything legible, like fingerprint 1.1. The rest of them were hashes of 12 bytes, I think, in hexadecimal. We couldn't decode them in a way, but we noted that down. Then we opened them in CAD software, Fusion 360 and AutoCAD, and we started moving around, trying to see if anything was inside the models. So we basically scanned in the entire thing from all directions, top, bottom, side to side, and we couldn't find anything for most of the files. Like only the fingerprint had the QR code that was very easily discernible. We also noticed on the Emmy Award that there could be a barcode by the way that the lines are formed, white and black, if you can form them like that. But it couldn't lead anywhere because there were no markings that said where it began and where it ended. We couldn't figure it out. That's it.
Okay, thank you.
Yeah, thank you. It's a really nice presentation and very details per suspect. So I wonder, like, what you mentioned, like, when you open the VS Code, I'm just curious, like, do you apply any like Gen AI like tools which analyze the file and somehow like you try that approach, or like does that help?
I can take this one. So we actually browse through them with the mouse to see abnormalities that were apparent, but then we used Control F to find any links. We clicked at www dot or HTTP but we didn't find anything through that means of searching. We did not try AI. We did not think AI would help, because since there was no link, there was no comment that would have shown a clue, and the files were opening properly, then that meant that no clue was outside of comments. So since no comment had a clue and no clue was outside the comments, we couldn't, there was no reason to search with AI.
Also, the files are really big, so such models cannot really handle them very well, I think.
Thank you.
Thank you guys once again for your presentation. You guys did a fantastic job. If you're able to stop sharing, yep, thank you. And we can have our last team go ahead and start presenting. So anyone from Team Tesseract?
Am I audible?
Yes.
Yeah, sure. So I'm from the team Tesseract. Actually, we don't have a presentation right now. We just have this detailed report that was shared to you. Is that okay if we can present that? That would be okay.
Yeah.
Yeah, okay. Sorry. Yeah.
Any findings that you guys have, you can go ahead and share.
Just to confirm, we don't have any audio now, correct?
Yeah.
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 And screen share. No,
Sharing it.
no.
Yep.
I
there you go.
believe,
Yep.
yeah, I believe my screen is as well. Okay, so so this is like the more descriptive way of how we approach the problem. It was quite frankly very challenging, honestly. So the works that we done is that we were like sent these step files, and we were looking at the different step files, what they meant and things. So honestly, what we figured out was, we thought that we actually ended up thinking if this was actually connected to Lady Gaga, because a lot of things where one was talking about the Paris Eiffel Tower, and then there was something about the Emmy Award, and something that was related to NYU, and there was a camera and there was a crown. So we so all these, as far as we discussed, it was like all heading to the direction of like Lady Gaga. But then the problem statement was more on the thief side, the encryption side and things. So, but we were not able to quite settle on that, and we still don't know if there's any connection with this character. But these were some of the clues that we connected, and we thought that it has some relation. This problem has to do something with the character Lady Gaga, and maybe with the passcodes or something. So we just kept it in there. And then one interesting piece was when we came to the step one file, we found that there was like this fingerprint like structure, uh, which had this QR code, in it. Seemingly it was like a puzzle. So what we tried to do is, we had two approaches to carry on. So the one we had was, we had like the Adobe Photoshop and the CV to Python library. So we were like more on the image processing side of things. So we tried like the several ways to see what this QR code can give us. And then we tried like changing the curves, the red and blues of the curves. So that was one thing. And then the first thing we tried like the inversion. And the next one, we tried to like look for particular color ranges and isolate the color range, and to see if the QR code can actually turn up something, like if it was like a grayscale or white or something unique would turn out. And we tried like sampling a lot of different colors. And what we found out was eventually that we also had this idea that there was actually a fingerprint on that was actually holding this the QR code. So we also thought that what if the background color of this a fingerprint and the color that was in this QR code, if removed from this QR code, would actually result in something that is unique. So we also had that idea, and then we tried to map the color from the one in the fingerprint with this one, and tried removing that. And also we were trying to play around with those colors. So that was the violet color that was coded CAD1FF. And then later on, we also saw that there was actually another code, interestingly, which was F54F94. So this code actually came up in this link, which has this link when we actually tried doing this operation below. So when we're trying to work with the color range, we ended up in a black and white QR code of this sort. So when we tried scanning this ended up taking us to this website, and we had this QR code, and there was this hex color code, and this hex color code denoted the a light pink color. So we were also seeing that if the light pink color could eventually take us somewhere to the original website or something, but we were not like very lucky with it. And this was one way. And we also tried several other approaches, like more of the sampling approaches. And then we tried to see if we can actually adjust the RGB histogram, because we also went through like a lot of research papers that did say that there was like a quantitative correlation like between the QR color coded cryptographic analysis, as well as the histogram that was actually taken away from it. So we were also seeing that what if we change histograms, and what is it going to give us, or if these histogram curves itself does say something about the QR code. So we were also analyzing that. And then we were also looking at the color balance. We were seeing that what if we could isolate like all the QR code colors into just the primary ones, just the red, the blue, and the green. Because one of the research papers, they were doing that, and we thought that maybe what if we could do that. So we were also trying on the color balance of stuff. And these were like selective color isolation. So we're just selectively isolating the colors and seeing what could be done out of that. And then we also tried like a lot of image processing methods that was like done via these the CV2 Python library. So that was from the OpenCV library. So this was like inspired like from one of the research papers, the code that we tried. So it does like several of these steps, like adjusting the global luminescence, the color thresholds. But ultimately what it does is it actually gets the green color range, the blue color, as well as the other major color ranges. So either is it a CMY plane, or is it an RGB plane? So it isolates these colors, and then it actually tries to performs the binarization process. And then there's a whole lot of steps, like these are the inbuilts, the salt and pepper refinement, and all these steps are followed. There's like a local luminescence enhancement. So all these are followed. But even then, like after following these steps, we found out that these steps were actually very specific to the photos, and there was a lot of arbitrary values that were tweaked in the code to get this running properly for each picture. And since we didn't really have a lot of time to iterate over the code, we would not really end up in a very good position with this thing. So this was another approach. And then finally what we did was we actually came to this we were searching a lot about the color based QR code, and we ended up with something called the Zixing decoder. And then interestingly, when we actually put our file into it, it actually gave us the same website, and there was a set of raw bytes value that we actually got in. So what happened is, once we got these values, what we did is we tried to like recognize what kind of encryption methods does work with these raw bytes, and we found out that the encryption method that does work is an XOR encryption type, and it's, to be more precise, it's an XOR cipher kind of encryption type. And then what we did is we converted the hexadecimals that were in this, we converted into bytes, and then we stored them as a byte array. And then we had to like remove the white spaces, then convert the hex strings into bytes. And then from there on, we tried to like find the exact key length for like each of the datas, because we wanted to see if the key lengths were like 8 whether was it like 6 or was it like 4 or 2. So the basic idea is that we have this hexadecimal, and then we're converting this hexadecimal values to the decimal values, and then finally these decimal values are mapped to the ASCII equivalent. And what we do is like we are trying to actually map these values, and we are trying to find the GCD of the distances like between these two values, and we are trying like different multiples, like for example 2 6 8 and 10. So we're finding like each of these multiples, and we're trying to figure out which of these exact key lengths would actually work for this problem. So that's how we did it. Then we went for like grouping the bytes by the key position. So what we did is we went to the modulo of 6. So our first group 0 had like 0 to 6, 6 to 12, and all those corresponding values, and then 1 to 7 and 7 to 13. So the way we like intuitively approached for key length taking as 6 was we actually used this approach of finding the GCD, and we figured out that the GCD distances are like ranging from between 1 to 10, and looking at the number of the number of bytes that we had, we figure out that it must be somewhere like either 2, 4 or a 6. So we tried like working with all these 3 key lengths, and we figured out that 6 actually worked pretty well because it actually converged the problem. And then we perform this frequency analysis. So it has the bytes and how much of these bytes are occurring, what are the frequency of each of these bytes occurrences. So that's what we have put here. And then we tried for applying like just common English words like secret, orange, monkey, or purple, and we just tried to test that secret key in this. And then interestingly, what happens is there is an ASCII byte in the hexadecimal code conversion from the decimal to ASCII that actually gives you an ASCII value of secret. So the way we performed it is we have coded that thing, the entire stuff. But what happens is in the terminal, although we get the code as secret, it does not necessarily decipher into a legible ASCII character. So this is how much actually we progressed in this thing. That's it from me.
Yeah.
Yeah. Any questions?
Thank you. It's very
Yeah.
detailed.
Yeah,
Nice
thank
to
you so much.
see like the code.
Yeah,
So
sure.
I have one quick question. So have you do any analyze on those 3D models, like opening the CAD, like SolidWorks, and explore from there?
As for we did actually look at like a lot of, we did open the step files in the text format, and we did look a lot into those codes, but then we were not actually able to find a lot in it, and that's why we had to stick with one of this QR code, and we just went on analyzing that rather than analyzing the other, because we felt that the others were given as just a means of distraction, because we thought it was a possibility that, so we just stuck with this QR code thing to see how much we can get through that.
Thank you.
Yeah, thank you.
And maybe a follow-up to that question. So you mentioned opening up the text files.
Yeah, sure.
Can you talk about, at least initially, presumably you went through all of the CAD files to see which ones you might want to delve further in, like the one with the QR code that you described here. Can you talk about what things you were looking for and maybe that preliminary scan in the CAD files?
Yeah, sure. So what we were looking is like, so I did say that we had this color in the fingerprint behind. So even in the before performing all this image processing based analysis, we were also seeing that if there was any hint of this specific color codes that were actually appearing directly in this in the form of code in the text files. But I think that the exact or the similar color codes were not approaching in the text files that we opened up. So I think we directly left that approach, and I think there was like a few more analysis done on the STL files, but since I was like more involved on the parts based on the vision thing, I would say, as for my knowledge, this is what we have done with the STL, with the aspect of STL file points of view. Yeah, with the point of view. Yeah.
Understood. Thanks.
Yeah.
Thank you very much for your presentation.
Yeah.
The code honestly went over my head a whole lot, but I
Yeah,
can tell
sure.
you guys did a whole lot of work on it, and so
Sure,
great
sure.
job for your effort.
Yeah, sure. If you're interested, I could even explain the code of exactly how the things work. I have written it up with an example, but since the time was limited, I was not able to put a lot of that into my report. Honestly, we couldn't come up with the even the PPT, so there was not much time. Yeah,
Okay.
thank you so much.
Right.
Thank you for understanding. Yeah, I appreciate
Right.
it.
Thank you so much.
Yeah, thank you so much.
So when will we announce the results? Tomorrow?
So we will be announcing the results tomorrow as part of the Hack3D competition. Not Hack3D, the Seesaw competition announcements. And following that, there will be an email and a LinkedIn post congratulating you all. But before that, the judges need to deliberate. So we thank you all for coming out here today. Thank you to the teams. Thank you to the VIP team. And we will see you all again next year for the 10th Hack3D competition.